Okay, we're going to talk about non-standard normal distribution. We're going to be finding percentages related to scores, and we're going to hear the word Z-score. Okay, so here's the example. You have IQ scores. The mean was 100, and the standard deviation, which has this little circle with a top tail kind of thing, the standard deviation is 15. Okay, so the first example I did was one that would appear on the curve because if we think about our normal distribution curve, 100 is our mean, and if we go up a standard deviation, that would be 115, and if we went down a standard deviation, it would be 85. So I'm asking you what percent fall between 85 and 115. Okay? Now, if you convert this to a normal curve, okay, so that's non-normal. A normal curve would have a mean of 0 and standard deviations of 1, 2, and 3. And 115 is equivalent to 1 standard deviation above, and 85 is equal to 1 standard deviation below. So in other words, 115 has a Z-score of 1, exactly 1. Okay? And 85 has a Z-score of exactly -1. Okay, so what you're going to do is you're going to go to your chart. Okay? It's kind of hard to see. There we go. So I'm looking for 1.00, and I can see there that it's 0.3413. So that represents the area that's between the mean and that Z-score. Okay? And likewise on the other side, 0.3413. Okay, so now you can see that the total percent between that would be that amount times 2. So 0.6826. In other words, 68.26% of the scores are going to fall between 85 and 115. That's what that means. Okay, and we had talked about that in the normal distribution curve, that our numbers were 68, 95, between 2 was 95, right? And between 3 was 99.7. Okay, now let's talk about scores that aren't going to be perfectly 100 plus 15 plus 15, right? 127. Okay, that's not going to be a perfect Z-score. Okay, so if we think about our curve, okay, our non-standard one, we have 100, 115, right? Standard deviation again would be, the next one would be 130. So you can see that I'm about right there, right? And I'm going to find out the percent of people who scored below that. Okay, so we're going to convert this to a standard curve. Okay, so 100 becomes 0, right? 115 would be 1, 130 would be 2. Okay, so what is 127? Okay, I know it's going to be like 1 point something, right? Close to 2 because it's just under 130. Okay, so we're going to use this formula, the Z-score. And we're going to go, it's the score that you have, subtract the mean over the standard deviation. Okay, so your score minus the mean divided by the standard deviation. Okay, so what does that come out to be? And we get 1.8. Okay, so now what do we do with that? We go to our chart. 1.80. Okay, you see 0 on the top. 1.80 is 0.4641. Okay, so here's what's been happening. The z-score is 1.8. 0.4641 is this area to the mean. And what do you think's on this side? That should be exactly 0.5, right? Because it's half of the curve. So the scores below 127 would end up being 0.9641. So 96.41% of the people, that's what that means, were below 127. Okay, so if you scored a 127, that's pretty good because there's not many people that scored above you, right? Not even 4% of people above you. Okay, find the percent between 90 and 110. Okay, so here we go. Z scores. 90, subtract the mean over the standard deviation. Okay, that has a Z score of negative 0.67. And 110 minus 100 divided by 15, that is a positive 0.67. So we are on a standard curve looking at Z scores of 0.67 and negative 0.67. Okay, so 0.6 on this, and then you got to go across to 0.7, and you see the 0.2486. Okay, so there is my percent between that score and the mean, and obviously on this side it's going to be the same because it's the same Z score in a positive and negative way. Okay, so that ends up being 0.4972. So that is saying the percent. So 49.72% of the scores are between 90 and 110. Okay, if you are a genius, what's the percent above you? Okay, so let's go Z score first. Okay, so the Z score that correlates to 140 is 2.67. So we know on a curve, here's our 0, 2.67 is up there. Okay, so this time it's saying above you. So that's what we're looking for. There's not much above that, right? Because this is a 3. Okay, so we're going to look up the Z score of 2.67. So 2.6, and then we go across to the 7, 0.4962. Okay, so 0.4962 is this area in here, but that's not my answer. I want this little portion. So in this piece, I have 0.5, so I'm going to subtract. Okay, does that make sense? So that's a pretty low percent. So if I move that decimal, only 0.38% of the people would score above you if you reach the genius level. Okay, two more questions here. The probability that Z is between 2.4 and 1.2. Okay, so let's go on our normal curve. Okay, so that is what I'm trying to find. So let's go to the chart and let's look up the values that we see there. Okay, so 2.4 is 0.4981. And 1.2, so 1.2 is 0.3849. Okay, so what does this mean? Okay, let's think about this visual. That is 0.4981, and this is 0.3849. So to get this piece, I would need to subtract. So 0.1069 or 10.69%. Okay, you can leave it in either form if it doesn't specify. Okay, and last one here. So here's our mean, 0, negative 1.3, and 1.8. And this is what we want to know, the percent probability to be between there. So we got to go to the chart. 1.8 is 0.4641. Okay, so that is there, and we're going to the chart, and negative 1.3, so 0.4032. Okay, and so now you can see that I want this and that, so I'm going to have to add. Okay, so now it's 0.8673 is the probability of being between the scores.